Last time, we talked about how data formats evolve. Today, we're diving into how data survives when parts of the system fail. What if your database could keep running even if one of its copies died? That's the power of replication, but it comes with a price. That opens up the real question for this episode. How do you make sure your data stays consistent when copies of it are spread across different nodes? Here is the framing that makes the rest of the episode easier to hear. We are not just naming concepts here. We are trying to spot the moment where the system starts pushing back. How do you make sure your data stays consistent when copies of it are spread across different nodes? Picture this. Imagine you're sending a message to two friends. One says, "I got it," before you send the next. The other just nods and walks away. Which one is more reliable? Where it gets tricky is this. Synchronous replication blocks writes if a follower fails. Asynchronous replication risks data loss if the leader crashes. The useful shift is this. Synchronous replication gives you safety, but it can slow things down. Asynchronous gives you speed, but it risks losing data. So the design move is this. Use synchronous replication for critical data and asynchronous for non-critical writes. Take this moment. You need to add a new node to your cluster. How do you make sure it has the same data as the others without stopping the system? The catch is here. Copying files directly can lead to data inconsistencies. Locking the database for sync is not ideal for availability. What should really land is this. Use replication logs to keep followers in sync without downtime. This ensures data consistency without halting the system, so the practical move is always use log-based replication for setting up new followers. Imagine the system on a rough day. A follower falls behind. How do you bring it back up without disrupting the rest of the system? This is the part teams usually feel too late. If a follower is too far behind, catching up could cause delays or data inconsistencies. The deeper lesson is this. Follower recovery is a delicate balance between speed and correctness. You need to know when to pause or slow down. The engineering response is, implement a catch-up mechanism that allows followers to recover without blocking writes. Here is the version that shows up in production. The leader node crashes. How do you make sure the system keeps running without losing data? And here is the pressure point. If the leader fails and there's no synchronous follower, you might lose recent writes. The thing to notice is this. Failover is a critical part of replication. You need a way to promote a follower to leader quickly and safely. So, what do you change? Start here. Design your system to detect leader failures and promote a follower with minimal disruption. Now zoom out. Replication is the glue that keeps data safe across a distributed system, but it's not without its costs. One more quick lens helps here. You write a record, then try to read it back. It's not there. Why is that happening? Reading your own writes is a guarantee that your system must provide, but it's not always easy to achieve. If there is one thing to keep, make it this. Choose your replication strategy carefully. Speed, safety, and availability are all fighting for space. Once you've got your data replicated, the next question is, how do you split it across the network without breaking things?